Everybody, I'll be talking about xqerl. Yeah, the database layer for xqerl. Now, it's more of a data layer. I wouldn't call it a database, but it is. Yeah, for those who don't know me, Zachary Dean. I wrote xqerl, still writing xqerl, the xqerl 3.1 processor in Erlang. And yeah, just last year, I introduced it here. So how is that going? Yeah, implemented a few new features. The serialization feature, which was a big thing, and then xQuery Update Facility 3.0. I used 3.0 even though it's not a recommendation because it was just a really good fit in the way I built everything else. It was a really quick thing with the update lists and using multiple processes. Features it already had, yeah, the higher order function feature and the module feature. And I also got to a few extras that I wanted to get done. REST-XQ, big thing, that's pretty neat. HTTP client as well, and the file module. And now, there's a little space on that slide. I guess I'll have to do the task module when there's a spec for it, right? Yeah, so why did I add a data layer to xqerl? I could have, I guess, not done it. But yeah, the update facility needed something cool to do. It's updating data, so it needs to have database to do that too. Yeah, it makes the entire system useful. And yeah, building databases in Erlang is trendy. Yeah, it still is, I think. Yeah, so what's it look like on the inside? Well, it doesn't look like this on the inside, but all documents are retrieved or written by their document URI. And the base path of the URI is the collection. That is the database. The documents aren't stored on disk that way, totally different way, but you can imagine it this way and say like 2019 has all the months and then all the days as well as subfolded. Using a collection at xqerl.org documents 2019, you get all months and days. In it, it's seen as one. So each database, internal, which there can be many, many, many databases, is just a handful of processes, actually 2 handfuls. It's 10, I think. And each one handles a little portion of the XML database. It's really similar to what Adam said with the shred down. Names are just IDs. Everything is normalized. And then these processes handle each portion of what they do. So names, namespaces. The node table is where all the nodes are packed into bits that I can get at them really, really fast. And then here the DB lock is the whole locking mechanism to maintain transactions, to make sure that there's only either a bunch of concurrent reads or one write at a time. And also the path table is very important because that's the commit of a transaction. If a document can be seen in that path table, that means it is completely in the database. Before then, you can't reference it at all. So here's a few limits, because there's always limitations when you shred data like this or bit pack anything. You have to say, okay, how many things should I be able to address? So here are namespaces in one database, 1024. I think that's a pretty good limit. I mean, maybe someone has a use case where that doesn't fit. I don't know. Node names in the database, 500,000. It's also prefix, local name combinations. Should be okay. 128 elements or attributes per element. Also, I don't know, maybe that doesn't fit in some use cases, but I just kind of decided 7 bits was enough. Now, the unique text values per database, every string value is deduped. It only occurs once in the database. And I use a hash value that can overflow, or there can be 16 hash collisions per hash. So that limits the number of strings that can come in because there will be collisions once you get to a certain size of data. And it can be with random data around 650 million. Could be a lot less depending on the data, could be a little bit more. But therefore the text and the attribute string values are split. They're in 2 different places. Nodes per database, no limit. It's not really true because every operating system has a limit on the size of the file. But yeah, it would be in the exabyte range. And then number of databases in one xqerl system, a 32-bit integer, so 4 billion, I think that should cover it. And now if that wasn't enough, because it's in Erlang, we also have distribution. So you can have multiple nodes, and a node being one instance of xqerl running. So these nodes here, they don't necessarily have to be on different physical machines. They can be on the same machine. They can be on different machines. They can be geographically separated, whatever, or any combination thereof. And they can all speak to each other, see each other, and call each other's data. Of course, if they're over a network, you have that lag. So why do all this? Flexibility. So you can choose how to save your data. You could say, okay, I want one monolithic database, a bunch of little xqerl instances running on one machine. They're all going crazy. Or even distributed. They're going all which directions. You know, maybe they're about to replicate or something. I don't know. Get it? So yeah, to increase this flexibility, eventually, this is something I haven't done yet, but really do have planned, is pluggable backends. So to set up an API that accepts XPath statements and then returns the in-memory node structure that is expected, or even a functional one that works as an iterator. That would be pretty neat, because then it could put xqerl, say, on top of a Fusion DB, or an SQL, or any relational or NoSQL, anything. So what's still missing? Well, the pluggable backends I just said, XPath rewrite and simplification. That isn't done yet, so it does everything the hard way. It keeps reverse axes, things like that, and tries to run them, which means it's not so cool. That needs to be done, and then something else. Yeah, indexes, there are none. They haven't been done yet. Main reason for that, I was looking for any other Erlang solution that would do this, act as an index. There have been some, but yeah, they got abandoned 7 years ago, 2 years ago. Certain other products, they've completely abandoned all the Erlang solution ones and gone to Lucene or RocksDB. So yeah, still a decision to make there if gonna go that route. So anything else missing? I don't know. It's my first database. And actually, I think the people here know, you guys know more, what an XML database should do, or should be able to do. So yeah, let me know. Hit me up, I'm here. Create an issue on GitHub, feature request, something like that. Because I only have so many ideas. And yeah, community input does matter on this. It's something brand new. Can go in any direction. If you have a use case, send it my way. Yeah. And thank you. That's really all I have. Got us back on schedule.
Yeah, excellent. Thank you very much. It's interesting to see how big progress you can make since the last year. So do we have questions? Oh, no. Everyone is looking forward. Dinner, not yet. We haven't finished yet. Okay, there is a question.
It's all very impressive, but I would like to know about the maturity of the current state. For example, there was this big test suit by the W3C. Did you already test it against it?
Against the update facility, you mean? Or what portion?
No, I mean the xqerl implementation as a whole.
Yes, of course, yeah. All 29,000 tests or whatever. It's at 99.85% passing. There's, I think, maybe 12, 13 errors in there. And it has to do with, because I'm compiling code, that you can't look into imported modules.
So you think it's really already ready for production use?
If you don't mind the memory usage of pulling entire documents in at one time and doing everything in memory the hard way with XPath, sure, yeah.
That's cool.
If you don't mind.
Okay, do we have more questions? If not, then thank you again. Let's do it.